Hello, everyone. My name is Parth Bhatt. I'm a third-year PhD candidate from Michigan Technological Universities. Today, I'll be talking with you all my research, which is about mapping natural communities of Hiawatha National Forest using machine learning algorithms. To protect and manage any ecosystem, it is crucial to understand them at different levels. And to do that, appropriate classification scheme is important for any landscape, whether on the ground or using remotely sensed data. The purpose of this study is to map and classify coastal wetlands and adjacent forest areas of Hiawatha using natural communities of Michigan classification scheme. Using this detailed information, we are dividing Hiawatha's complex landscape into easily understandable component. There have been several past studies that has been done for land use land cover classification in Michigan using field data, GPS data, national wetlands inventory maps, radar, and Landsat data, as well as UAS data. Hiawatha National Forest is located in the central and eastern part of Michigan's Upper Peninsula. It manages the greatest acreage of coastal wetlands in the Great Lakes Basin. It has a diverse land, water, plant, and animal community. Approximately 46% of the total forest area is classified as wetlands. Our study maps both the west and east unit of Hiawatha. In the west unit, we have 11 we are mapping 11 watershed, out of which we are using one test site, which is Sturgeon River Delta, drawn here in black polygon. Total area is 470 square kilometer. Whereas in the east unit, there are 8 watershed, out of which there are 2 test sites we chose, Point Oshenbe and Carp River Mouth. The total size of the 8 watershed is 637 square kilometer. Some of the key questions we are answering here is that, does high resolution imagery coupled with machine learning algorithms can classify complex coastal wetlands more accurately than traditional parametric classification algorithms or not? We are evaluating variables such as soil, topography, vegetation indices, and texture and hydrogeomorphological variables. We're using high resolution 4-band NAIP imagery, which has 0.60 centimeter resolution. We're using 1 meter LiDAR. We are using UAS imagery to visually look at the area and identify natural communities. In our method, we are using NAIP imagery. We are generating image enhancement components such as principal components and independent components. Using the ground data and site knowledge and the PCA, we are drawing careful boundaries around the natural communities. Within these natural communities, we generate random points, and we use those points to train the classifiers such as random forest and support vector machines. We also generated vegetation indices and texture using the NAIP imagery. We stack all the layer or all the variables together and then run the final classifier on that entire stacked imagery. In our results, we are using 2 study sites, as I mentioned before, Sturgeon River Delta and Point Oshenbe. Both of them has diverse upland and lowland ecosystem, including variety of wetland habitat from open water to shrubs and forested wetlands, variety of deciduous to coniferous tree species as well. As I mentioned before, the principal components helped us drew the reference vegetation community map boundaries. Using these boundaries, we generated random points within these boundaries, and we used those points to train the classifier and eventually applying that class and training to the entire imagery. With Sturgeon River Delta, we achieved 85% with random forest, whereas 83% overall accuracy with support vector machines. We identified 5 different vegetation community classes in Sturgeon River Delta. Whereas with Point Oshenbe, we identified 7 different community classes. We achieved 96% overall accuracy with random forest and 97% with SVM. Even though SVM has a little bit higher accuracy, we still chose random forest as it didn't overpredict the area like SVM. The future work will involve using the same workflow method, and that will be applied to the watersheds I mentioned previously for both the east and west unit. These maps will be then used by the Hiawatha authorities to manage and monitor the forest and wetland areas better. Here are some of the references that I used in this study. The unique thing about this study is that no one in the past has mapped Hiawatha at such large scale or using such high resolution imagery. If you guys have any questions or concern, you should be able to find my email on forestry site of Michigan Technological University. I would like to thank Michigan Technological University for U.S. Forest Service, GeoConvergence Workshop, National Science Foundation, and American Geographical Society for giving me this opportunity to talk today. Thank you.